Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 45 to 50 of the Cbest Mathematics practice questions. All right, let's take a look at question 45. It reads, use the statements below to answer the question that follows. So the statement is, there will be softball practice every Saturday throughout the season with the following exceptions. If it rains, softball practice will be cancelled. There is no softball practice on the third Saturday of the month. Alright, so before we go ahead and answer this question, let's go ahead and do a real quick review on conditional statements, also known as if-then statements. Now, what are conditional statements? Conditional statements are statements that are composed of two parts. So you have if P, then you have Q. Okay? Now, if-then statements are composed of two parts, as indicated earlier. The first part is known as the hypothesis or the initial condition. Okay? So if P is known as the hypothesis or initial condition. Now, if the hypothesis is satisfied, then you can arrive at the conclusion. Okay, so these are what conditional statements are known as. For example, think about geometry. If a polygon has three sides, then it is a triangle. Okay, so that's an example of a conditional statement. And that's what we're dealing with here. But one thing to note is that sometimes your hypothesis can be comprised of multiple conditions. Okay? And then we have to use the appropriate operator to determine what the relationship between the conditions are. Do all the conditions have to be satisfied, or do at least one or more of them have to be satisfied? Okay, so before we take a look at this problem, let's take a look at a tip real quick. So concerning conditional statements with multiple conditions or multiple hypotheses, if you have the word and in the hypothesis, this basically means that all the conditions, all the components of the hypothesis must be satisfied. Okay? So all the conditions of the hypothesis must be satisfied. That's what the word and means. Okay? Now, if you have the word or, that means that at least one of the hypotheses must be satisfied. Okay? So at least one of the hypotheses must be satisfied. Okay? All right. Now, let's see which of these conditions, either and or situation, is applicable to what we're dealing with here. Okay? So it says there will be softball practice every Saturday throughout the season with the following exceptions. So we have two exceptions there. Okay? Either it's raining or it's the third Saturday of the month. Okay? So it's either one or the other. There's no and there. So let's go ahead and write this down in a conditional statements form. So we'll say if. Now we're going to have to break this statement into two parts, okay? Because we have two hypotheses here. Hypothesis 1 is it rains, or it's raining. It is raining. Okay? Or hypothesis number 2 is it's the third Saturday. Is the third Saturday. Now, if any of these two initial conditions are satisfied, or any of these hypotheses are satisfied, then we'll have a conclusion, which is that there is going to be no softball, or softball will be canceled. Okay? So there is no softball practice. Softball practice. Okay, so you can see what kind of if-then statement we're dealing with here. This is a situation where we have multiple conditions for the hypothesis, where at least one of them is sufficient to arrive at the conclusion. Okay, so now let's take a look at these options. Which of these must be true given this conditional statement? Option letter A. Note it states here that if it is Saturday but there is no softball. Okay, so we already have the conclusion. There is no softball. Option A says it is raining. The initial condition in this statement says it is Saturday. Option A will be correct if hypothesis number 1 was the only condition necessary to conclude that there is no softball. But is raining or not, is that the only condition necessary to determine if there's no softball practice? The answer is no. The third Saturday is another condition that could result in the cancellation of softball practice. So option A is not correct because that is not the only hypothesis that we have. Option letter B, it is the third Saturday of the month. Well, if it is the third Saturday of the month, there will be no softball practice. That's true. But in this statement here, it just states that it is Saturday. Option B will be correct if the third Saturday of the month is the only condition to arrive at the only hypothesis or initial condition to arrive at the conclusion that there is going to be no softball. But is this the only condition? The answer is no. It could either be the third Saturday or it could be raining on that Saturday. So option B is not sufficient for us to arrive at the conclusion. Alrighty. Now option C, it says it is raining and, see the key word there, the operator, and it is the third Saturday of the month. Now this statement will be true, this condition will be true if both of these two must occur in order for there to be the cancellation of softball. But if you look at the statement here, you clearly see that if it's raining, that's sufficient for the cancellation. Or if it's the third Saturday, that's sufficient. This is an or condition or situation, so option C is not correct because at least one of them is sufficient to cancel softball practice. Okay, and if you take a look at option D, it is raining or it is the third Saturday of the month. That is exactly what we have here. So we can clearly see that the correct answer is option letter D. All right, let's take a look at problem 46. It says, use the table below to answer the question that follows. So we have the table, and this is the question. The partial school schedule above shows the start times and end times of class periods. Except for lunch, all classes are the same length. What is the missing start time for fifth period? Now, there are two methods we can use to solve this problem. I'm going to show you both methods. The first method, method 1, is the class length method. Okay, so we're going to take a look at the class length. What we're going to do is use the table provided to calculate how long the class length is. We can pick any class period because we know that all the classes have the same length as indicated here. So if we can figure out how long the class length is, then we can use the end time and the class length to figure out the start time for period number 5. Okay? So let's write down the formula that relates all three measures. So the class period, or we can call it the class length, the class length is basically the end time minus the start time. Okay? So if we subtract these two, we'll figure out what the class length is. Okay, so which period do we want to pick? It doesn't really matter which one we pick. Let's go with the fourth period. All right? So with the fourth period, the class length, which should be the same as every other period, is going to be the end time of 11:36 minus the start time of 10:40. Now let's orient this vertically to subtract. Okay, so we're gonna, so I can carry over my differences. So we have 11:36 minus 10:40. Okay, now what you notice is that we're subtracting 40 minutes from 36 minutes. 40 is greater than 36 minutes, so we have to borrow one from the hours to add to this 36 minutes. So it's big enough for us to subtract 40 minutes. Okay, so if you borrow an hour and transfer it to the minute column, how many minutes are you borrowing in actuality? There are 60 minutes in an hour. So when you borrow an hour and transfer it to the minutes column, what you're doing is you're adding 60 minutes. Okay, so this problem becomes 11 hours minus 1 hour takes you back to 10. And then when you add the 60, the hour, which is equivalent to 60 minutes that you borrowed, to the 36 minutes, that will give you 96 minutes. Now we'll subtract 10:40 from that time. Now this looks better because we have enough minutes to take away 40. So if you do your arithmetic, you calculate the difference, you end up with 56 minutes. Okay, this is how long each class period is. So now that we know the class length, we can now use that and the end time for period 5 to compute the start time. Okay, so using this equation, if we solve for start time, we can easily see that the start time is simply going to be the end time take away the class length. Okay, how long the class is. If you subtract how long the class is from the end time, then you end up with the start time. Basically, we're rolling back the clock. That's what we're doing. Okay, so we have the end time for fifth period as 1:15, and we're subtracting the class length, which is 0 hours and 56 minutes. Now let's carry out the subtraction. Let's orient this vertically so we can easily keep track of our carryovers. So we have 1:15 minus 56 minutes. 0 hours and 56 minutes. Now if we inspect the minutes that we're subtracting here, you will notice that we have 56 minutes to be subtracted from 15 minutes. Okay, we do not have enough minutes to subtract 56 minutes from because 15 is less than 56. So what do? We have to carry over. Okay, we go to the hours column. We'll borrow 1 hour and transfer it to the minutes column. 1 hour is equivalent to 60 minutes. Okay, we did the same carry over in the previous part when we're looking for the class length. That's exactly what we're doing here. So when you take away an hour from 1 p.m., that takes you back, it rotates your clock 1 full hour back to what? What's before 1 o'clock? 12 o'clock, right? So it takes you back to 12 p.m. And then you add your 60 minutes to 15 minutes, so that's 75 minutes. And we are subtracting the class length, which is 56 minutes. This looks much better because we now have enough minutes to subtract 56. If we carry out our subtraction, 5 is smaller than 6, so just borrow 1 from there. That's 6, carry 1. 15 minus 6 is 9. 6 minus 5 is 1. And then 12 minus 0 is 12. So the start time is basically 12:19 p.m. Answer is option letter B. Okay, so that's one way of solving this problem, by using the length of a class period and the end time to compute the start time. Now let me show you another method. This is basically carried out by looking at the patterns of the end time and the start time for each period. It even applies to lunch. Okay, so I'm going to call this end method 2 as the end start pattern. I want to advise you to use this method as your first method of choice. Although it works, this is much more concrete. Method 1 is much more concrete. You can use method 2 just to verify that your answer is correct. Okay? Now, if you take a look at the end time and the start time for a period and a period after it, what you notice is that there is a pattern. Okay, so from 9:36 to 9:40, how many minutes is that? That's 4 minutes plus 4. Okay, from 10:36 to 10:40, end time for third period to start time for fourth period, what do you notice? 4 minutes, another 4 minutes. And then from the end of fourth to the start of lunch, what do you notice? There's another 4 minutes. So it looks like in this school, there's a 4 minutes passing time, even for lunch. What do you expect to happen between the end of lunch and the beginning of fifth? It's safe to assume that the same pattern will apply. Okay, so it's kind of risky because in some schools, they might alter their passing times, and that might be the case here. Okay, so we're just assuming that the same pattern carries over to the time period between lunch and fifth. So we follow the same pattern, which basically indicates that 4 minutes is added to each end time to get the next start time. Following that pattern, we're just going to conclude that we just take the end time from lunch, which is 12:15, and just simply add that 4 minutes. Okay, let's write this properly. Since we have hours and minutes, so we have 0 hours and 4 minutes. We just simply add that 4 minutes that's constantly being added to the end time to determine the next start time, and we will get 12 minutes and 12 hours and 19 minutes p.m. And that agrees with the answer that we got earlier in method 1. 12:19 p.m. So we're confident that our answer is option letter B. Okay, let's take a look at problem 47. It reads, use the chart below to answer the question that follows. So we have the US and world silver production in metric tons. And then it says, how many metric tons of silver were produced outside the United States in 1950? So we're going to focus our attention on the 1950 row. Okay, we're going to look at the world and the US silver production values. Now, one thing you want to note is that this is a subset type problem. Okay, we have the so you have to note that United States is part of the world. Okay, that's important. I know it's obvious, but that's very important when you're solving this problem. So let's say that we have a larger set. This is the world. This is the silver production for the entire world. Okay, so let's call this world. Now, the silver production of the United States is a subset of the whole world production. So it's in it. Okay, so this is for US. Now, outside this United States boundary right here, we have the remainder of the world. Okay, that's what we're looking for. So we're looking for this exterior part right here. Okay, so in order to calculate that, what we'll simply do is we're going to take the silver production of the whole world and equate that to the sum of the production of silver in US plus that outside of US. Then we'll solve the resulting algebraic equation for the silver production outside the US. Okay, so the total number of silver produced by the whole world is equal to the number of tons of silver that the United States produces plus the number of tons of silver that's produced outside the US. Okay? So if we want to solve for the number of tons of silver produced outside the US, we're just going to substitute these two values into this equation and solve for the missing value. Okay, so number of silver that's produced by the whole world in 1950 is 6,323. And then the amount of tons of silver produced in the United States is 1,347. Okay, that added to the number of silver produced outside the US will give us this value of 6,323. So in order for us to find the number of silver produced outside the US, we'll simply subtract the world production from, subtract the US production from the world production. So we'll subtract 1,347 from both sides of this resulting algebraic equation, and that should give us our final answer. So we subtract it. Let's switch it around. The number of tons of silver produced outside the US, if we carry out the subtraction, this is 3, cancel, carry 1 over, 13 minus 7 is 6, and then we have to borrow another 1, this is 2, carry 1 over, 11 minus 4 is 7, 2, 5, carry 1 over, 12 minus 3 is 9, and then 5 minus 1 is 4. Okay, so 4,976 metric tons of silver are produced outside the US. Our answer is option letter A. Okay? Now let's look at problem 48. It reads, use the graph below to answer the question that follows. So we have the U.S. energy consumption, nuclear versus hydroelectric, presented here. Question, according to the graph, what was the maximum difference in energy consumption between the two sources of energy in any one of the years shown? Okay, so we have 1970, 1975, 1980, 1985, and 1990. So graphically, what does the difference in the sources of energy mean? Graphically, let's note a point. The maximum difference graphically is basically the maximum separation. Okay? The greater the separation between the two curves, the greater the difference. Okay, so we're looking for the year that has the biggest separation. Now, if you look at all the years, we can clearly see that 1970 and 1990 have the widest separation, but we can't tell exactly which one is bigger, but they have the largest. We are not going to consider 75, 80, or 85 because the separation is less than these two. Okay, so when I mean separation, I'm talking about the space right here. All right. So the wider the separation, the bigger the difference is because we're subtracting the values. Okay, so let's just put down, write down a statement. The years that appear to have the maximum difference. Remember, maximum difference, we're talking about the maximum separation. The years that appear to have the maximum difference are 1970 and 1990. Okay, so what we're going to do is we're going to compute the actual difference in these 2 years, and whichever is greater, okay, we're looking for maximum. Whichever is greater, that will be our answer. So let's start with, so let's call 1970 the first one, and then call this the second one, okay? So if you look at the first one, for 1970, what's the difference? The difference is this output right here, which kind of looks like 2.5. So 2.5 minus, right here is 0.5, so in between it, this could be 0.25, a quarter. Okay, so let's call that 0.25 and 2.5. Let me use arrows to extend it so you can see exactly what I'm doing here. Just give me a second. Let's make this really skinny. Okay, so this right here is 0.25 and that one is 2.5. Okay, let's write that in. So you don't have to be 100% accurate here. If you look at the answers you get, you'll be able to tell, estimate what the correct answer is. So this is 2.5. So we want to, the difference is basically subtracting these two values. So 2.5 minus 0.25. If we carry out the subtraction, we'll end up with 2.25. Okay? Now let's go to the second year that has a very large separation, close to 1970. We're letting the numbers tell us what the correct answer is. So for 1990, what do we have? What's the separation here? The upper limit looks like 6.25 or 6.2. Let's just call it 6.2 because it's not right in the middle. So I'm going to call that 6.2, okay? You could call it 6.25. You still get the correct answer. So the separation for 1990 is going to be the maximum, which is 6.2 minus the upper one minus the lower one, which is the hydroelectric is 3. Okay, so 3.0. When you subtract 6.2 from 3.0, you end up with 2 minus 0 is just 2, and then 6 minus 3 is 3, 3.2. So which of this is bigger? This is bigger, right? So since this is bigger, that means it has a it basically represents the maximum difference for all the years because it has the biggest separation. Our answer is option letter D. All right, let's take a look at 49. It says use the chart below to answer the question that follows. So we are given a pie chart of the percent of total crop yield in 1999. We're given the percentages for different farms, but we do not have the value for Central Farm. So the question reads, what percent of the total crop yield did the Central Farm generate in 1999? Okay, so let's go ahead and set up a formula first that relates all the measures, and then we'll substitute to get an algebraic equation which we can solve to find the missing farm percentage. Okay, so what relates all the percentages here? Well, we have the total crop yield. Let's write this down. The total crop yield. When we're considering the total crop yield, we're looking at the entire pie chart. Okay, if you have a full circle, that's everything. Okay, the total crop yield can be determined by computing the sum of the West Farm's yield, West Farm, plus East Farm, plus South Farm, plus North Farm, plus what? Central Farm. Okay, if we add all these percentages of the different farms, that would give us the total crop yield. So what percentage is a full circle, a complete circle? What percentage is it? That's the whole pie. A whole pie is 100%. Okay, so 100% is going to be equal to the West Farm's percentage, which is 24%, plus East Farm's percentage, which is 21%, plus South Farm's percentage, 7%, plus North Farm's percentage, 31%, plus Central Farm's percentage, which is just Central Farm. That's our unknown. This is the variable that we're looking for in this algebraic equation that we just created. Okay, so all we just have to do is solve for Central Farm's percentage by adding these values up, subtracting it from both sides, and we are done. So let's go ahead and do it. So if you compute the sum, 24 plus, I'll just do it step by step, okay? Since we're not using calculators here. 24 plus 21 is 45. 7 plus 31 is 38. Add that to Central Farm's percentage, and that should give us 100. Okay, so we have 100 equals 45 plus 38 is 83, plus Central Farm's percentage. And then to get Central Farm's percentage isolated, you simply subtract 83 from both sides. And that will give us the Central Farm's percentage, 100 minus 83, which is 17%. Okay, so our answer is option letter A. Okay, let's take a look at problem number 50, the last one in this review series. It reads, use the graph below to answer the question that follows. So we're given this graph, the graph of year versus sales of thousands of dollars, and the statement goes, the graph shows the sales of a commodity over a 60-year period. Between what years did sales increase by the greatest amount? Okay, so if you look at this setup right here, we have a 10-year separation, a constant 10-year separation between the years. That is also applicable to the options that we have. What we're looking for is the increase, the greatest increase. Okay, so thinking about mathematics, we're looking at the rise. Since all the runs are equal, we're looking at the rise. Which rise is the greatest? The greatest rise will yield the greatest increase. Alrighty, so let's divvy up our intervals. So the first interval is called at 1, interval 1. And then we have interval 2. And then we have interval 3. And then this is interval 4. And then the last one, interval number 5. So just by inspecting the steepness of the lines, the steepest line basically should yield the greatest increase. You can clearly see that line 2 is the steepest. Line 5 is horizontal. This is 0. There is no increase in the fifth interval. Okay, so just by inspection, you can automatically see that this is the answer. All right, but let's assume that we didn't observe that. Okay, we're gonna actually calculate the rise on each interval to know for certainty that interval 2 yields the greatest increase. Okay, so let's do interval 1. So interval 1, what you're looking for is your rise. Okay, think about rise over run, your slope triangle. Okay, we're not looking at the runs here because all the runs are the same, so that doesn't count. So we're looking at for the rise. Okay, so let's do the rise for interval 1. So for interval 1, the rise is basically y2 minus y1. Okay, so y2 in this scenario is 100 minus y1, which is 50, and that gives you a rise of 50. Interval number 2, which should give us the biggest one. We're just looking at the rise here. Okay, so what's the rise? y2 minus y1. Our y2 is 200, our y1 is 100. So for interval 2, our rise is going to be 200 minus 100, which yields a rise of 100. That shouldn't surprise us because we expect this to be pretty big compared to the others. Now, what's the story with interval 3 from 1960 to 1970? Let's draw our slope triangle. What's the rise here? y2 minus y1 again. So for interval 3, our rise is going to be 250 is y2 minus y1, which is 200. If you carry out the subtraction, you get 50. Oh, the same rise as interval 1. If you extend this line and this line, you find out that these two lines will be parallel. They have the same slope, which basically means they have the same rise and run if you reduce them to their simplest forms. Interval number 4. What's the story there? It's not as steep as any of these, so we should expect a smaller increase. So let's compute what the rise is here for this slope triangle. We're going to do rise, we're going to compute the rise, which is y2 minus y1. So the rise, y2 here is between 300 and 250, right in the center. Okay, what am I talking about? Let me show you. This rise right here is right in the center. So what's in the middle of 300 and 250? It's 275, right? Just average these two. Okay, so y2 minus y1 is going to be 275 minus y1, which is 250. And our rise for 1972, 1980 is going to be 25. That shouldn't surprise us. Okay, so this is interval 4. And this is 3 right here. 3, 2, 1. Okay, are we done yet? No, there's one more, right? We have interval number 5 right here between 1980 and 1990. So let's compute the rise in this case. So we're going to have to rise from here to here. Okay, so for interval 5, our rise is y2 minus y1. y2 is 275. Guess what y1 is? Exactly the same as y2. There is no rise, no increase here. 275 minus 275 is 0. So we're looking for the greatest increase. The biggest or the greatest is interval 2. Okay? So interval 2 goes from 1950 to 1960. Our answer is option letter B. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the Cbest examination, do give us a thumbs up. Your positive feedback is very valuable and supportive to us. If you have any questions about the contents of this presentation, just place your questions or comments in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other cool math tutorials such as this. More preparation resources can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.